Hello, my name is Rich Howard, owner of Architectural Builder Supply. This video is to bring you a closer look at the Bommer, number BB5002-454N-630. This is a ball bearing 5.5, pardon me, 5.5, a ball bearing 5 by 4.5 inch hinge is what it is. Not an uncommon hinge at all, although it's a somewhat of a less common derivative, really, as a result of it being 4.5 inch wide. It's a 5 inch tall as well. 5 inch hinge, 4.5 wide, made of solid stainless, standard weight, ball bearing, security pin. The ideal, I think, application for this hinge, standard weight 5 by 4.5, stainless steel security pin. Exterior door that swings out. Especially one that's in a more corrosive environment like you would have in a coastal application, where salt is in the air, and the salt with the humidity does work over time to degrade the finish and the base material. Standard weight, very likely that you have a door that's likely not extreme high volume, but 5 inch in the sense that perhaps you have a door that's either that's one of the two. Standard weight in the sense that you have a standard volume door, 5 inch where you are compensating over 4.5 inch, where maybe you've got some higher volume on the door, or maybe you've got a door that's one caliber heavier, like a 16 gauge door versus a an 18 gauge door. You might go with a 5 inch. The extra half inch in height, I've read that it's about 20% greater capacity of carrying the weight of the door. So I'd probably be tempted, if this was a 3070 16 gauge door, I probably would go with a 5 inch hinge. Exterior application where stainless is required, I would only go to a heavy weight when that was required by the application, meaning the volume was such that it would drive that when we're talking 3.0. When you get to doors wider than 3'4", you're going to see 5 inches standard. So if you had a 3670 18 gauge hollow metal door, yeah, 5 inch tall is going to be considered typical for that. That's what you're going to want, even though it's unusual. Well, it's not specified necessarily correctly, and I'm saying that 5 inch tall would be correct for a 3.6 door. Because it's a wider door. But when you go to these concepts, higher volume, a little bit heavier, and then wider door, you need to start thinking about taller hinge, thicker hinge. This door in particular is a low volume use, this project, low volume use 3070 16 gauge door, exterior application at a water treatment plant. So low volume. So I'm really just thinking, standard weight for that kind of scenario. But it's a little bit heavier than standard. I suppose an argument could be made to go to a heavyweight hinge itself, and then stick with a 4.5 inch. I'm a fan of the greater height, is the bottom line. I feel the greater height of the steel does a really good job at keeping that door running correctly. Low volume, very little, if any, chance for any abusive use, so I'm not worried about the thinner gauge being succumbing to that sort of behavior, because I don't think it's going to happen. Now, why 4.5 inch wide? Well, the vertical axis of pivoting. Normally, you'd have a 5 inch by 5 inch hinge, 4.5, 4.5, 4 by 4, 3.5, 3.5, 8 by 8. This all runs together. That doesn't mean it's the right hinge. And in this instance, a 5 by 5 is not the best hinge to use. And in fact, a 4.5 inch hinge is better. A 4 inch hinge would have worked perfectly, but it wasn't available. And what I mean by that is the vertical axis of pivoting. You want that as close to the center of the thickness of the door as possible to make the hanging device as efficient as possible. There is the concept of the vertical axis of pivoting. When I take the door, which is over here, and I swing the door out, do I need to get around some sort of a clearance situation by moving that vertical axis of pivoting out further to throw the door out further when it gets to 180 degrees? And in this instance, I don't need that at all. It is a block wall, and the frame is basically up close to the exterior side of the wall, and there's just a very small reveal, so that when we run the formula for determining width of hinge, which we'll do in this video, 4.5. Four would work, but 4.5 is what we went with because that's the closest that we can get our hands on. The point of all of that is, just because it's 5-inch tall, don't assume 5-inch is the best hinge. It's not for the first reason I mentioned. The second reason is it's less sightly. It's unsightly to see a lot of projecting hardware. Did a job for a client last year at a country club where the main entry doors to the country club, 3680 mahogany, style and rail, glass in the top half, panel in the bottom half, had 5x5 hinges. Well, these are just 1 3/4 thick doors. The doors can only go to 90 degree, and I said, we were changing all the hardware, and I said to the client, would you rather a 4.5-inch hinge or maybe a 4-inch hinge if I can get my hands on it? He says, no, leave it just the way it is. Well, okay, but here's why I'm saying that. It's smarter. No, just leave it the way it is. A 4.5 or a 4 would have been better in that application. And I first noticed it as I'm visually scanning the door. I said, boy, those hinge barrels really stick out far off the face of the frame, unnecessarily far. And the difference between 5 and 4.5 wide is only 1/4 inch. But you don't want projecting hardware, is the bottom line. I think everyone's walked down a hallway and cracked the crown of their watch on projecting hardware, a hinge, a lever, things of that nature. So this is a BB5002. Let's dissect the part number. It's BB, it's ball bearing, on a standard weight hinge, which should be 140 thousandths on this hinge. There would be 2 bearing packets on this hinge. My caliper tells me 146. Is it 146 or 140? 146. Boy, that is on the money. That's rare. That it's literally 0.146. So 146 thousandths. There would be 2 bearing packets because it's what we call standard weight. There are 3 weights when it comes to hinges. Residential weight, which is about about 96 thousandths. Standard weight, depending on the height of the hinge, 134 thousandths. If it's a standard weight 4.5 or 146 thousandths. Then you get up, if this was a heavyweight hinge, it would be 190 thousandths. The leaf thickness just gets greater. The 5002 means a number of things. It means it's a 5-knuckle hinge, exposed bearings. It means that it is a full mortise hinge. You can see from the bend, or the swag is the term we use, on the hinge leaves, that when they're brought parallel, they're meant to be mortised flush to the edge of the door and frame. The 2 in the part number means it's made of a non-ferrous base material, specifically stainless, is what that means. Yeah, I think I've covered all of the bases. 5-knuckle, full mortise, steel, stainless steel base material. The 545 is Bommer's way of saying the hinge is 5-inch, and the height is always the first dimension on hinges like this, and it's 4.5-inch wide. Okay, their size code takes a little getting used to, and I'll show you where the catalog is if you need to draw on that to make sure you're speccing the right size hinge. But this is a 545. If it was a 5x5, it would just be a 500. The N after the part number means non-removable pin. That's that little set screw that's there. So when the door is closed, that set screw, you can barely see evidence of it there. You can't get to that set screw when the door is closed at all. That's to prevent the pin, or all but prevent the pin, from being driven out. So when you go to hang the door, you would loosen that set screw, if you do it the way I do it. Loosen that set screw, drive the pin out, attach both of the leaves to the door and frame, bring the door up to it, bring the door up to the frame, tap those pins down on all 3 or 4 locations, whatever, and then tighten that set screw. That's how I do it. That is a security feature, one of a few security features, which we'll look at the catalog and talk more about that. Then the 630, that means 2 things. It means it's made of stainless steel, and that it has a brushed finish. That's also what's called a natural finish, and 630, also known as US 32D, is the most durable of all finishes. So when people will ask you for, I need the most durable finish, it is literally this, 630, where the base material is just simply brushed. There's no plating, nothing done to it. This would be the most durable finish for an exterior application. This is going to include cardboard shims. They will use cardboard shims to separate the hinges when they ship them, but it's also there to allow you to shim the door. If you have a fire-rated door, don't use cardboard shims. That's not permissible. As the joke goes, if you're going to use cardboard as a shim on a fire door, use your competitor's business card. That's not permissible on a fire door. Use steel shims. And then it will come with fasteners. It will come with... now, what's interesting about this is... I specified all machine screws. Making sure that I've got all of them. Let's pause this video while I do that. Sorry, I needed to make sure before they go to the job that I had enough machine screws. Well, what the factory did was, because I know this is a hollow metal door and frame, I specified, well, it's actually TMS, template machine screws, all template machine screws. Well, they certainly sent me enough template machine screws, but they included wood screws as well, which I don't need at all. They're not going to be used. I would expect the customer might keep these stainless steel screws. Number 12 inch and a quarter flat head, flat threaded to the head stainless steel wood screws. I would suggest the client keeps those. The point of specifying to the factory, twofold: don't send me what I don't need, because some customer may ask, what do I do with this? You don't want to present it to the person to begin with, only for that person to say, what do I do with this? If there's a hardware schedule, they're obligated to follow that schedule the way it's called out in the part number and install it as inferred by the part number. And when we call out all template machine screws, there should only be machine screws in there. You don't want someone saying, I've got this whole coffee can of these extra screws that you've sent me. I've literally had people tell me that over and over for years. If the factory elects to send them, fine, but they really ought not. They should just package it the way it's been specified. And if you don't specify it, they will send it out their standard method. Now, the other reason to specify it is the obvious, to make sure you get what you need. Imagine if this was a fiberglass door, that they were installing into an existing aluminum frame, and it wasn't specified what screws to get, and perhaps you don't get enough fasteners. Maybe they send all machine screws in that instance. Specifying it allows the factory to get it right for you, so that on Saturday morning when you're hanging the door, you're not around looking for stainless steel base material screws. That's not an easy thing to conjure at the last minute from your local, complete disarray home center, and you're looking for a specialty screw. Let's switch to the screen view now, and let's take a closer look at all the supporting information. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, let's take a little closer look at this hinge. Speaking of that, let's look at some photographs that we have. Here is the box, the label on the box, I should say. They're priced and sold per hinge. If you happen to buy 3, they'll likely ship them in one box, but that is not a mandated rule. It's just generally how it goes with hinges of this size. If you ordered a larger hinge, like 8x8 or 6x6, there's probably only 2 in a box. You order them per hinge. There's our hinge. Just showing the front of the hinge, or the face of the hinge. That shows the swag, the bend on the leaves. This is like the genetic code of a hinge. As you change the code, you change the hinge. If that wasn't bent, it would be a full surface. If it was bent in some other fashion, it might be a raised barrel, or it might be a half surface. Could be lots of things. The back side of the hinge. Just a close-up showing the texture a little bit more, and someone's, including mine, fingerprints. Show a much closer up on the brushing along with the Bommer logo, the shims that come with, and then the Fastener Package, or at least a representation of the Fastener Package. There is extended description information down below. I'll leave that to you to read. I've already said all of this. There is what we call a cut sheet. It's more of a template. Let's take a look at it. This will give you the dimensions and locations of the screw holes on this hinge. This document is what is called a template. The location of these holes is also what's called the template pattern. Whoever makes the door and frame, or the hinge for that matter, if they put their locations in what is the template pattern for that size hinge, it will be these exact dimensional properties. Exactly. This template, this document, also has another question that people also ask. What is the edge of the leaf to the swag line? That's the A dimension. On our hinge, it is 1 7/8. They do have a 4-inch wide listed. I think they came back and said they couldn't make it. I forgot what happened. Columns are based on base material. Rows are different part numbers. A 5 or a BB5 or an LB5, those are all, they don't have any LB5 here, but a 5 or a BB5 is a 5-knuckle hinge. An LB is a 3-knuckle hinge. Well, an 8 or an LB8 is a 3-knuckle hinge. So that's a nice document to have. Now, let's do this. There is a link below this video as seen here to the manufacturer's page, and when we click on that, and from this link we can pull up not only all of the Bommer products that we sell by means of this horizontal navigation as seen here, but also a link to the manufacturer's website, a relatively new design of their website. Maybe in 2020 they did this. Probably the best-selling hinge from Bommer in the history of Bommer. That's the ubiquitous 3029 series. That's a double-acting spring hinge that's been cloned and copied and counterfeited by countless people, but this is the original right there. Lots of material that they have here when it comes to spring-assisted or spring-governed hinges, double and single-acting. But the product catalog is here, and this is a worthwhile dive. Before we do that, I've taken out of the product catalog and just added the how-to order matrix here. This is the how to order matrix, and I refer to this document so often that I just leave a quick link to it on the manufacturer's page right here. And it's because, well, I don't remember all of the size codes. You know, what is a half surface 4.5? Well, it's 045. I wouldn't remember that. I have to look it up. Doesn't matter if you remember it or not. You have to know where to find it. But this allows you to deconstruct their part number system. Now, the link here to the manufacturer's catalog, this is going to be super handy for us to look at. All good hinge catalogs will have encyclopedic documentation in the beginning of the catalog. Bommer is no exception. There are a couple of others. Well, there are three others I think of that do an above-average job, in addition to Bommer. A weight chart of doors, average frequency tables, how to determine the hinge height is here. And you'll note they show 36 to 48. Go with a 5-inch hinge. Now, determining hinge width. So we've got a hinge that's not square, it's rectangular. Why did I come up with 4.5 inch? Well, there is a formula for this. And it's here. So the formula is pretty simple and straightforward, but it allows you to determine how wide of a hinge you need based on this drawing that's here. They have a table that just simply tells you what you need. It's right here. You don't have to work the formula, but let's work the formula. It's door thickness minus backset times 2 plus clearance plus inset equals the hinge width. Okay, let's go over that. And if you want to write this, well, I'll write it down. You don't have to write it down. Bear with me. There it is. So it's door thickness minus back set times 2 plus clearance plus inset. The door thickness is obvious. The hinge back set is the amount of the door that's not been prepped away here by the hinge. You multiply that sum times 2. You add the clearance dimension and any inset. So the clearance is obvious. From the face of the whatever, wall, jamb, brick mold, casing, chair rail, to the face of the door when you're parallel, plus the inset. And this is a grossly exaggerated inset drawing. The face of the frame to the face of the door. Hollow metal doors are going to have a small amount of inset. Very small, 3/32, something small like that. Aluminum storefront can have an inset, but it can also be very commonly flush as well. Wood doors are commonly flush. So you have to know the inset. No matter what, it's a small dimension, unless, of course, it's a huge dimension. And an example of that would be an 18-inch thick wall where you have an 18-inch deep wood frame, and you've got a pair of doors that are hung in the center of that 18-inch wall. And that's a real example. The original state capitol building of the state of Iowa, built in the mid-19th century. There's no structural steel that's happening to hold the weight of their assembly room was on the second floor. Imagine how hot that was in the summer. So they've got exceptionally thick walls, and those doors were centered in that very deep jam depth. So the inset was huge. They had epically huge wide throw hinges, which they didn't need at all because there was no clearance required at all. What they didn't have was a raised barrel hinge. What would have worked much better would have been just simply a raised barrel hinge, which would have, really, really deep. Tiny little door in here. They had literally wide throw hinges like this. Oh, all they really needed was they could have swung those doors to 180 degree because there was no problem, but the doors would have been so far off parallel, the clearance that would have been netted from that application would have been huge. A raised barrel hinge, and it goes back to the swag, when you bend the hinge in a weird way, like I said earlier, you really change the DNA of the hinge. That's a raised barrel hinge. They could have installed that there. It would have went to 90 degree. I'm not familiar with a wide throw raised barrel variant. That would have been ideal. It would have got them to where they had to go without such a huge hinge. But anyway, so let's just run through this. Door thickness is 1 3/4 minus the back set. That's typically 1/4 inch, but not always. So that's 1.5 inches times 2 is 3. The clearance on my application was basically 0. There was no clearance. So right now we're at 3 inch. My inset was less than 1/8 of an inch. The rule is you go to the next largest commercially available hinge. 4 inch would have worked perfectly. I couldn't get a 4 inch, so I had to go to 4.5. So that's how you run this formula. This is really why you're running a wide throw hinge formula, a formula for determining hinge width, when you have a clearance issue. And an example of clearance would be chair rail, brick mold, drive-it, stucco that's been applied, and you have to get to 180 degrees. And that's why you would run this. Very simple, very straightforward. That's how I determined why I needed the hinge that I indicated that I ended up needing. Okay. The rest of this catalog continues with the definitions of hinges and what to know, how to apply the knowledge. If you deal in hardware at all, whether you're a distributor or an architect or a specifier or an installer or a manufacturer, you should familiarize yourself with someone's catalog like Bommer. Read and absorb and learn everything in there, because this is the governing document when it comes to hinges. Their catalog is also full of all things Bommer related. Commercial hinges, architectural hinges, institutional hinges, aluminum continuous geared hinges. They have other material than hinges when it's just standard hinges. As I said earlier, they have a comprehensive offering of all things spring assisted hinges as well. This is a cool hinge. This is what would be a full surface swing clear is what this is. Well, I can see it right there, forgive me. So I guess I was cheating, had the chance to cheat. This is a half surface hinge. How that bend affects the hinge. This is a, I'm not going to look. This is going to be a half surface wide throw. The leaf is mounted to the surface of the door. The other leaf is to the jamb normally, and that offset, that vertical offset of pivoting is kicked over. So is it a swing clear? It's a swing clear. Half surface. Pretty neat. You will occasionally see hinges like this out in the wild. You definitely will. Spring hinges, single acting spring hinges. As I said earlier, their ubiquitous 3029 series of double acting hinges is here as well. Probably the last thing that I would point out to you in the catalog is their lavatory hardware. They make lavatory hardware, latches, not latches, bolts, keepers, occupancy indicators, toilet partition mounting brackets, thumb turns for high-end lavatory applications. High-end because it's all solid brass and available in 15 or 20 architectural finishes. Whatever you can do on brass as a base material, they can do. You'll see this in high-end hotel applications, a law library restroom, a restroom of a law library of a Big Ten university is full of it, absolutely full of it, full of that hardware, continuous geared hinges. Let's wrap up this video on camera. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Now, we've talked quite a bit about this hinge. You know, stainless, 5-inch, standard weight, heavyweight, the width, security options, which I'm going to talk more about right now because I forgot to do that. So there are different types of pins. This is what would be called a removable pin, because it is. You can remove the pin. You can loosen that set screw and drive the pin out. Once you seat that, tighten the screw, it's all but removable. But certain applications require more security than that. And that additional security would be called a security stud. It's basically a piece of metal about the diameter of a dime that's physically attached to the hinge leaf. And it's maybe a 1/4 inch thick. There's a hole drilled in the other leaf so that when the door closes, that stud, is what they call it, goes into the hole. If you were to separate if you were to drive the pin out, you still can't separate the leaves because that is there. Then they also have reverse or maximum security studs, where they have those same discs on the back of the hinge, and they go into the plate of the door and the frame reinforcement as well. The American terminal of the Miami airport doors leading out to the parking garage, they have a combination of security stud and NRP, and you will see those run together, is where you'll see them. Okay. The last thing I'd like to point out to you is the Bommer logo. Right above it, it says Made in USA, a fact that Bommer is quite proud of, as am I to represent them. Other people's logo might say USA on it, but it doesn't say Made in USA. That may or may not be of any importance to you. It is to me, and it most absolutely is to the people at Bommer. It's a fact that they're quite proud of, as am I to represent them. Any questions on the BB5002 454N and a 630 finish, or any other Bommer product, please feel free to reach out to us. And thank you. Again, thank you for watching, and if you've enjoyed this video, please click thumbs up. Please subscribe and maybe even send the video to someone that you know. Thank you.